Okay, now we're going to look at, on page 23, how we calculate the probabilities below a certain value. So first of all, let's look at the problem. And so we've got an example here about our student backpacks, which we've seen before. And this is again normally distributed, and it's got a mean of 3.3 and a standard deviation of 0.3. So the first thing we're going to do is draw our normal distribution and put those values onto the grid. Okay. So we've got our mean of 3.3 and our standard deviation of 0. What we want to do now is it's asked us to calculate the probability that the backpack weighs less than 3.5. So I'm going to locate 3.5 on my number line, which is above that mean of 3.3. And you can see that's where I've put the second line. And I want to find the area below that because it's talking about weighing less than 3.5. So we're looking at the area below. If I now think for a moment about the mean, and from the mean below, we know that because it's a symmetric distribution, that the whole area below the mean is going to add up to 0.5. So that's the first thing I'm going to note, is that that area on the left below the mean, that total area there, equals 0.5. So what do I actually need to do? Well, from the tables, the normal tables, this is the area, the orange area, this is the area I actually need to find out now to be able to calculate my total area. So let's think about, well, what is that? How do we do that? First of all, we are going to draw our normal distribution, and we're going to convert that x distribution to a z distribution. And the z distribution has a mean of 0 and a standard deviation of 1. Now, if we look at that graph, the areas that I've shaded on both the left-hand side and the right-hand side, those areas are the same. And we want to find the z value such that those two areas are identical. So, how do we do that? Well, we've got our formula, z equals x minus mu over sigma. And in this case, we've got our x value on the left there of 3.5 because we want the weights of backpacks less than 3.5 kilos. So we're going to have 3.5, take away the mean of 3.3, all divided by that standard deviation of 0.3. That gives us a z-score of 0.667. Now remember to round your answers to 3 decimal places because our tables go to 3 decimal places, so we want our answers to 3 decimal places. So if I go back to my diagram, my z distribution, I can now add that value of 0.667 to that diagram. And the last thing I want to do is find that area between 0 and 0.667. So we get it out our normal probability tables and we'll find that area. So if I'm going to write down the whole question, what is it actually trying to find? We're trying to find the probability that x is less than 3.5. And that's equal to our probability with our z-score. Remember our z-score we found here is 0.667. So the probability of being below that is the same. And we know that on the left-hand side, below the mean, that total probability adds up to 0.5. So then we just need to add on the extra probability that we get from our normal tables of being between 0 and 0.667. And that gives us a probability of 0.2477. Combine that together, and that means the total area below a backpack weight of 3.5 kilos is a probability of that happening is 0.7477 or 74%.